Hello, everyone, and welcome to this session. We are going to be doing a whole ton of live hacking today, and we're going to be talking about how you can find vulnerabilities within your applications in your Bitbucket cloud workflows natively within the Atlassian tooling. So a little bit about myself, your speaker today. My name is Simon Maple. I'm the field CTO at Sneak. I'm very much into the community work that I do, a lot of work around things like the virtual jug, around DevSecCon, the Secure Developer Podcast, and a whole ton of other things like that. My background is very Java oriented. The last 20 years, I've been a Java developer, and more pushing these days onto developer tooling, and in particular, Sneak, which is a developer tool for security and finding security issues and fixing security issues in your workflows. So today we're going to be talking about a cloud-native application that we're deploying using Bitbucket pipes and a Bitbucket workflow, and we're going to be pushing that across to the Google to AWS and EKS. Now, one of the things that we have seen over a number of years now is this transformation from a pre-cloud deployment into a cloud environment, and we can see this transition has caused a shift from the responsibility of a number of different services from the IT and the app services teams across to the developers. So if we look at it pre-cloud and look what a deployment looked like, you can see the developers here at the very top. They really think about the app code they write. This is their custom code they would write in their own IDE, and open source libs, libraries, frameworks, etc., that they pull in through their typical package managers. It could be anything from a POM XML that they're using Maven to pull in, or it could be something like a package JSON that they use it, allowing the NPM package manager to pull in. But a whole ton of libraries that they pull in to create half the application at least. This is really important with our rapid development and creating modern applications. But you can see when we come to deploy that, it sits on this large stack, and that stack is typically owned by the platform team, the IT team, the operations team managed by, and this is kind of more legacy style deployments. Now, when we think about what today's modern applications and modern stacks look like, we can see that much more is owned by the developer. And this could be anything from the application code that we just talked about across to containers, potentially Dockerfiles, etc., looking at Kubernetes config or any other Terraform scripts, those kind of things. And we can see much more owned by the developer, maintained by the developer, potentially checked into Bitbucket cloud repos, etc. And as a result, the developer needs to think about a ton more attack vectors that, from a security point of view, can affect their application, and that they need to think about when they're creating things like config, for example. We hear about misconfigurations, etc. So when we think about the tools that we need to use and the pieces of the application that we need to secure in the software supply chain, there is no longer just one small piece that a developer needs to think about. We obviously have the custom code at the tip of the iceberg, the custom code that we need to think about. This is the code that a developer will write in their IDE. Typically, we'll use SAST style tooling to statically look through our code and find common patterns that where vulnerabilities can exist. At Sneak, we have Sneak code, which can perform this kind of testing. We also have open source code, and this is where Sneak open source, which we'll show you in a bit within native integrations into Bitbucket. Sneak open source will find and fix vulnerabilities that exist in your known vulnerabilities in your libraries that you pull in to your application. Then we have containers in your infrastructure as code. So this is part of what you deploy your application into before pushing it into a production environment. So these containers can pull in hundreds of packages, many of which contains different vulnerabilities that can potentially be exploitable. And of course, infrastructure as code, the config and the code and the scripting that we use to automate our production environment, our containers and our config. Misconfigurations, a big critical issue that has affected many of S3 buckets, etc., that we've seen in the wild. This is a very important piece whereby misconfigurations can occur because typically developers don't necessarily know all the gotchas with config. So it's almost like what you don't put into your config files, which can sometimes lead to a misconfiguration. So without further ado, let's jump into some demo because we've only got a 30-minute session here. And I really want to talk about the application that we're going to be deploying. This is going to be deployed into Amazon's EKS as a Kubernetes application, but this is it's a Dockerfile, which Docker container, which drops into EKS. Now, this application is vulnerable. It's our application. It uses real-world libraries, and it is vulnerable. We're going to show you how to exploit this vulnerability, and then we're going to show you how scanning and fixing within Bitbucket pipes and Bitbucket pipelines can help us to eliminate these vulnerabilities in our application. So let's get going. First of all, I want to show you the application, and the application exists here in Bitbucket. It's a Node application, so you can see we have some JavaScript. We have our Bitbucket pipelines YAML here. Our Bitbucket, if I open that up, our Bitbucket YAML file has a number of different steps here. This is a sneak pipe here, you can see, and this sneak pipe takes in an API token. We're going to scan, and then this is an NPM project, so we're going to be scanning a package JSON. In this case, we're saying we're not going to break the build. We can choose whether we want to break the build as part of the part of when we run a pipeline, or whether we just say, you know what, we're going to accept vulnerabilities that are going to go through, and I'm going to deal with them after the case. So this is scanning our application code, in this case, our NPM application. Another step here that we are adding is going to be scanning and pushing our container image. So the first thing that we're going to need to do here is run the sneak scan. So this is very similar to previous step, but in this step, we're going to be running it against a Dockerfile rather than the application itself. So in this case, what we're going to be doing is scanning the Docker image to find any packages that are pulled in. We're going to create together that dependency graph of packages, identify where vulnerabilities exist against those packages at those versions, and in this case, again, we're not going to break the build, but it's going to be information that is going to be there in the pipeline. Again, we're going to be using sneak token, etc., and the build image name and things like that. The next thing we're going to be doing is going to be pushing our build, the image that we create. We're going to be pushing that across to AWS ECR, and this is going to be our container repository. So we're going to push that across. We obviously use a number of different variables here, which I'm adding to the pipeline, and our image name and a tag of the Bitbucket commit number here for this build. So now at this stage, we have scanned our application, we have scanned our container, we've put the built container into Amazon's ECR. And then the final stage, we're going to deploy. And deploying is going to be as simple as just effectively pushing it from ECR and pulling it into our EKS environment. So our EKS environment here is simply just going to consume the container into our cluster, sneak goof, and that's pretty much as simple as straightforward as it is. I've got all the setup already done on the Amazon side, and then after that, so this is the EKS run. After that, we're also going to be running some Dynatrace logic to see where events are driven from. So this is a deploy event where we'll be able to see that in Dynatrace as well. Dynatrace, of course, uses sneak under the covers to scan and see where vulnerabilities exist within runtimes as well. So that's our pipeline. We're going to scan, we're going to push that image across to ECR, and then we're going to deploy that in EKS. So there's our application. Now, here is the application, which is already running on Amazon EKS, and this is a goof to do application. So if I wanted to, I could do things like buy milk, and you can see there's also a runner happening in the background, which is adding some synthetic to-dos. This is just so that we get some activity on this application. So I can buy some milk, I can buy other things. The one thing I did want to show you, though, is if I was to just bring this up a little bit, is an about page. And this about page is being served from the public directory. Now, as an attacker, I can see that there is something serving a static file and about HTML from a public directory. So what I'm going to try to do is exploit this application using directory traversal. And directory traversal is the ability for me as an attacker, as a malicious individual, to try and break out of a directory that I should have access to, in this case, the public directory. And I'm going to break out of that and try and find some sensitive material somewhere else on the server. So first things first, let's grab that, move across to a terminal, and I'm going to, I'm going to curl that URL, and you can see there's our HTML. Yes, it looks just as good in a terminal as it does a browser. Now, I'm going to try a couple of things. First of all, I'm going to try without the about HTML. So this is the public directory. I should have access to it. But the question is, should I have access to a directory listing? In this case, I do. Whether you decide that to be a vulnerability or not, well, you're potentially giving a user more access, more information than they need. So are you providing a user with data that they shouldn't have? Potentially. So it depends on how you want your application to be used and how you want your users to interact with your public directory here. But what I want to do is directory traversal. So how am I going to traverse this? Well, a lot of you are probably thinking, well, in order, if I was to do this at a command, at a regular terminal and a command line, as if I was changing directory, I would try and do a // and so this is going to effectively cd ... us out of the public directory. So I try that, and what do we get? Well, it looks pretty good, but you can see synthetic to D. So this is actually the home page. You can see there's my buy milk, and there's my goof to do here. So we're at the home page. I'm at the home page because this is a vulnerability, and I'll give you some background information. This is a vulnerability in a package called ST, and ST is a node package which provides static serving or serving of static files. Now, as a result of this being a library that does this, it needs to recognize where directory traversal happens. And in this case, a .. is classic directory traversal. So it recognizes that, and it's trying to block us using those characters. Now, what we want to do as an attacker is circumvent that sanitization. So the best way of circumventing sanitization very often is encoding. Encoding allows us to represent these dots, but not as the character dot, but as URL encoding. And a URL encoding, a lot of you maybe will have seen in a browser a %20 or something like that, and that represents a space. A %2e represents is the coding for a dot. Now, if I was to execute this now, there we go. Let me make that a little bit smaller so you can see that all on one line. You'll be able to see the directory listing outside of the public directory, because there is the public directory there. So now we've performed the attack. We've performed a hack. We haven't breached any. We haven't effectively got any too sensitive information just yet. But we can start doing that now. You can see there's an app.js there. And as an attacker, I will start looking at this environment and start trying to learn from it. You've got an app.js, you've got a Dockerfile, you've got what else? A package JSON is a really interesting one. So if I can look at the app.js, all of a sudden, we can start seeing some secret tokens. There was also a db.js that I can take a look at. And you'll start seeing hard-coded information. You'll start seeing, in this case, I'm using Mongo, for example. You'll start gathering information. If I was to have a look at the package.json, this is a really interesting one, because now we can start seeing where all our direct packages are, our direct dependencies, and we can start identifying where other vulnerabilities exist that maybe gets us more executable or remote code execution style vulnerabilities that we could exploit. I'm actually doing this in a Docker container. So I know there's no user directive in that Docker file. As a result, I am running as a root user, which means I can kind of go all the way back to my root, and then from there, I could maybe get the etc password of that Docker container. I could get the etc shadow file of that Docker container, etc. And I can start learning much more information about this environment. So we've seen the vulnerability. Now let's see how we can defend against that in the last 15 minutes of this session. Okay, I'm going to go across over to Sneak. And from Sneak, what you'll see is I have already configured Bitbucket Cloud. And what this means is Bitbucket Cloud is one of the integrations in which we can pull code from a source code repository, from Bitbucket repository, into Sneak and start testing it. There are a number of other places I can kind of do this from, including CI, including IDE integrations, etc. But in this case, I'm going to be doing it in Bitbucket Cloud. Now, what I'm going to do is I'm going to go across and I'm going to pull in the repository which is associated with this pipeline. And instantly, if I click on view log, you'll see that it's straight away finding a whole bunch of different types of artifacts that it can test and it can scan. And if I refresh that, you'll see it's picking up more and more as we go. It's found a YAML file, another YAML file. So these are config files. It's found a sneak code file. So this is the source code, our custom code. It's found a package JSON file. So our package JSON is the artifact that shows the build system all the direct dependencies, and Sneak can work out the transitives from that. And it's also found a Dockerfile in which it can tell us which image we're using and which vulnerabilities that image is pulling in. So it's already fully tested all of that. And if I was to go back to the view all projects, you can see that was already successfully imported. And if I go and take a look at this environment, you can see all my artifacts that it's found and the vulnerabilities that have been pulled in. And also breakdown of high, medium, or low. So in this case, we're going to be going straight to the package JSON, and we're going to try and find that directory traversal. So let me just quickly show you the view here. We have issues, and this is the full list of vulnerabilities that exist in this application. We have the dependencies. This is the list of direct and transitive dependencies that are pulled in as a result of this application. We have remediation as well, which tell us which versions we can jump our packages up to eliminate one or more vulnerabilities that apply for that package. Now, in this case, when a developer is faced with this kind of information, we can do a couple of things, one of which is raise Jira issues. And as a new scan, this the UI here will determine that this is a vulnerability that a Jira issue has already been created for, and it will point us to that Jira issue. So I can click that and it will take me to that Jira issue, which in fact I created just earlier today. So I'm going to go back over to, back over to the Sneak UI. And from this UI, I'm going to find that directory traversal. There it is, directory traversal, and it's the ST library. So if I was to click on show more details, we'll find a whole bunch of information about this. You can see this is being introduced from 0.2.4. It's fixed in 0.2.5. You can see exactly where that vulnerable function is. This is the function that the vulnerability exists in, the vulnerable code exists in. You also have information which is provided to you by our security team. And in this case, you can see it's this encoding of the dot slashes which cause this issue. So we know what the remediation is. The remediation is to upgrade to version 0.2.5. This is the minimum version. There are much higher versions, but this is the minimum version with the fix in. There's also a whole bunch more information here, including CVSS scores, including the severity of the issue, and a priority score, which takes a lot of that into account, as well as whether a fix is available, whether an exploit is available for this issue. Now, I could do a couple of things. In this case, I can create a Jira issue if I wanted to, and I can choose, where I'm going to add this. So I might attach this to Matthias, sorry, I should say this is from me, but I might attach this to be a Matthias issue that he's going to fix. It provides a description with more information about the vulnerability, etc. And I can raise that if I want. Of course, in this case, what I'm going to do is actually fix it. So I'm going to click on fix this vulnerability. Now, because I have imported this project from Bitbucket, I can equally send pull requests back to Bitbucket to fix these vulnerabilities. Now, this vulnerability, as you can see here, has now been selected by this UI, and I can now click on open a fix pull request. Now, what Sneak will do is it'll either provide a patch or upgrade you to the minimum version required, which in this case, as we saw, was jumping up to 0.25. And if I was to come back here and click on files, you'll see we've updated the package JSON up to 0.25. A couple of other things that I'll mention. We also test your licenses. So we, as part of this pull request, because we imported this from Bitbucket, we are now adding tests within Bitbucket to make sure every pull request, the delta change in those pull requests are tested for new security issues or new license issues. In this case, there are no new license issues. There are no new security issues created by this. So this seems a reasonable pull request to merge. Of course, I would normally run a whole bunch of tests and things like that, but in this case, I'm just going to merge this. In this case, you can see there's not really a huge amount here, so I'm just going to click on merge here. And that has now been merged into the master branch. If I was to now click on pipelines, and let's take a look at master branches here, you can see now, because I've merged that, this has now kicked off a new pipeline. And as a result of kicking off this pipeline, we're going to run through those stages again. And the first stage of that was to identify and scan your application. So it identifies the npm package JSON there and tests that. The second thing is it will test our container. And then the third thing is it will automatically push that to ECR and then upload that again to EKS. Now, one big thing that we, of course, want to think about is this the ideal place for us to be testing our code first? And the answer is, well, this is one of the first places which we can properly police it. A couple of things that we could do is I could go into Visual Studio Code, and within Visual Studio Code, I'm able as a developer to test it in my IDE. So I can see in my app.js, this is using something called vulncost, and vulncost is a Sneak plugin which will test my code, as you can see here, for vulnerabilities, and it's adding these annotations on the side to say how many vulnerabilities it's found. And if I was to click on this, so this is the ST package which we found the vulnerability in, I can click on the little balloon, I can click fix vulns, and what you'll see here is a quick sneak test on this version, the ST024, and you can see that it's found two direct vulnerabilities, one of which is the directory traversal, which we just exploited. And it's also got a couple of transitive packages, transitive dependencies or indirect dependencies that each have a vulnerability as well. Now, the remediation to fix all of these vulnerabilities is jumping up to version 1.2.2. So I can go to my package JSON if I wanted to and update my ST here to version 1.2.2. And you can see here, we're also scanning and testing each of these packages as well. Now, in my case, I just wanted to fix that one vulnerability, this one here, and that would have been to move to 0.2.5. So there are various places we can test a little bit earlier, but we want to test in multiple places, and we can't force developers to test here in VS Code. So when we actually go in and do our full test, that is when we do our full pull request, that is the first place in which we can say, okay, now I want to make sure that no code that goes into this repository is going to introduce new issues. This is the first place we can properly police. So this is a very, very important place. It's not the earliest, but it's an extremely important place to make sure that this is the first mandated area that we can absolutely test. So let's jump in and have a look at the pipeline to see what's happening. So in fact, it's just finished. Amazing. So I can see here that a report has been created, and this is using the Sneak Insights, the Bitbucket Insights, which show me that all the different vulnerabilities that exist in my application. And yes, this is a vulnerable application, so don't worry too much. But there are a lot of vulnerabilities here. You can see the breakdown between high sev, medium sev, low sev. You can see what's introducing it, and this is a great report that you're able to see. Now, if I wanted to break the build, again, I could just break the build, and anything which is out of policy that I'm not ignoring at this current time could stop the build from progressing, and as a result, we can stop new vulnerabilities from reaching our production environment. Okay, so we are now looking at a complete pipeline. It looks to be successful. We've deployed that into our runtime as well. So without further ado, let's try and run this again and see what happens. So this is exactly the same command that I literally just ran to show my shadow file. If I was to run that, now we get a cannot get. So we've fixed our vulnerability. Okay, we've fixed our vulnerability. We have done that through an automated or a pull request, which we initiated from Sneak, which pushed into Bitbucket. That Bitbucket pull request was fully tested in terms of not adding new license issues, not adding new security vulnerabilities. That a pipeline was automatically kicked off by Bitbucket, and it further tested the build. Whereas when we tested previously, it was looking more at just the artifacts, but now it was testing the built versions of the application to see there were no new vulnerabilities in our application, as well as our container. Then it pushed it into ECR and pushed it into EKS after that for us to test and validate that our vulnerability no longer exists. Okay, one more piece of that pipeline that I wanted to talk to you about. If I was to go back into my, oops, there we go. If I was to come back here, is the example I showed you there was about how we create an issue or a pull request, sorry, how we create a pull request based on a vulnerability, an issue that existed in our report. But what if we're not looking at our report? What if we're not pushing a pipeline at the time? What if a new vulnerability or a fix to a vulnerability exists or is newly found and we're not doing any pipeline work at all? Well, what Sneak will do, if I was to go back to let me find out, it's here. If I was to go back to my Sneak projects, what Sneak will do is you'll notice that each of these, while these were tested just moments ago, Sneak will also run these tests every single night. And if a new vulnerability is found or a new license issue or a new fix is available for an existing issue, a pull request will be automatically sent out directly to my Bitbucket Cloud instance. And that pull request will contain the necessary upgrade I need in order to fix that issue. Couple of other things. This is the application piece of it. Just to let you know that we can also test in our application here code analysis. So this is our Sneak code. And as a result, you can see a number of different issues that exist in this application, such as command injection. So the idea that a piece of user input here can be added into this exec function without being sanitized. So there's no sanitization happening here. We're doing some regex work, but there's no sanitization here happening to a piece of user input before it gets executed. And that's exactly what this is saying here. SQL injection is very, very similar. So in this case, we're grabbing the request body username and we're passing that into a database request without any sanitization. This is a raw from the HTTP request body. That's exactly what this is saying here. So you can find issues that exist in your custom code as well. So that's the SAST and the SCA. If I was to come back in here, you'll also take a look at the Dockerfile. And this Dockerfile is the Node 8 stretch, which, as you can see, contains 813 vulnerabilities. And here's the breakdown there. You can also see that we have a number of either a major upgrade or a number of alternative images that will massively reduce the number of vulnerabilities and significantly with the high sevs. And again, we're very actionable in how we make these recommendations. You can also see all the list of dependencies plus the packages where the vulnerabilities exist in and which versions they're fixed in. And finally, the last thing which we can test here is the YAML files. And with the YAML files, you will see a number of misconfigurations. So I can see here what the issues are, what the impact of my issue could be, in this case, a container running with full administrative root privileges, and what I need to do in order to fix that issue. And I can see exactly where this issue exists in my YAML file here. So I hope you enjoyed the session. Let me know if you have any questions or comments. You can reach out to me on Twitter, SJ Maple. Thank you very much for your attention and enjoy the rest of the conference.